Number 17. Each of the dot plots shown represents the number of glue sticks brought in by each student for two classes, Class A and Class B. Which statement best compares the standard deviations of the numbers of glue sticks brought in by each student for these two classes? Okay, so standard deviation is how far away the data points are from the average. So for a visual representation of that, here we go. This one on the left, the average, anytime you have a symmetrical set of data points, the shape is symmetrical, the same pattern is going left and right from that center point. Anytime that happens, and these are all the same distance apart, like 1 apart, 2 apart, whatever, that central point is the average. Always. It's just how it works out. So that's when it's symmetrical. When that happens, that's our average. That's our average. Okay. So here's what standard deviation is. On the left, these points, there's more points that are further away from the middle. On this one, on the right, more are in the middle, and there's fewer points that are far away from the middle. So which one is higher, which one is lower? On the left, this has a higher standard deviation. They are deviating more. That's what the word is. Deviation, coming from or related to deviate. Deviate is when you're going away from the path. You're going away from sort of the way you're supposed to go, shall we say. So you're deviating from it. You're doing something different. So our mean here is the norm, as it were. And here more points are deviating from it. So it has a higher standard deviation. This one, more are staying close to the middle. Fewer are deviating. So it has a lower standard deviation. Now look at our picture up here on the left. Let's look at this. These shapes are identical. We have the same shape, the exact same number of dots above, each number in this sequence. Does it matter that the numbers are different? It does not. They are all 1 apart. That's it. 1, 2, 3, 4, 5, 6, 7. Each of these is 1 apart. 14, 15, 16, etc. 1 apart. That's all that we have to see. Like, okay, they're the same number of steps and the same number of dots are present here. Do we have to do the mean? Do we have to find the average? We do not. Just knowing that each of these has 7 steps and that the first step has 1, second step has 1, the third step has 3, first step has 1, second step has 1, third step has 3, etc. That the steps are all the same and that each of these steps is the same distance apart from each other, they're going to have the same standard deviation. Wherever that average is, and I'm thinking it's probably going to be about there somewhere. Let's see. When I do this math, I'm guessing, I just feel like it's going to be between 5 and 6. I'm going to do the math afterwards and then put that up on the screen right now and see how right or wrong I was. But I'm guessing it's going to be about there. So let's assume that I got that right. Then this one's going to be about there somewhere. It's going to be at the same point relative on the number line. The dots are going to relate and deviate from that point the same because the shape of these dot plots is the same. So the standard deviation for these two dot plots is the same, and that is B. They are equal. And you will never have to calculate what that standard deviation is. And honestly, you shouldn't have to calculate the mean either. I think maybe I've seen one time where they had a table where they actually had numbers in the table and ask you the standard deviation between the tables. I'm thinking that's happened, but this type of thing is far more common, where they show you a dot plot. And the two types of dot plot I've seen are ones like this. Wow, that was a wonky rectangle. There are ones like this, where the shape of the dot plots is identical and the numbers at the bottom are different, and they're trying to trick you with that and say, oh, those numbers are more, so that must be more. Nope. Numbers are the same. The separation between the numbers at the bottom, the dot plots, are the same. Then the separation between the numbers at the bottom is the same. Standard deviation is the same. And the other variation looks like this that I have here on the right, where you have two sets where the numbers let's say, will be identical at the bottom. And they both will be symmetrical. And I didn't do this one with the same number of dots. But let's see if this one has 1, 2, 3, 1, 2, 3. So that's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can go 10, 11, go like that. There we go. So now they have the same number of dots. And they will say, all right, which one has, the higher or lower? How do they relate to each other? And it's always going to be this kind of thing where one says A is higher, and one says they're equal. One says A is lower, and one says we don't know. That's always your 4 choices. As of the time of the recording of this video, that's how it's always been presented. And then, yeah. So again, identical dot plots, identical jumps, 1, 1, 1, 1, 1, 1, up by 1, up by 1. Those are going to have the same standard deviation. If they are symmetrical, each symmetrical, and the numbers at the bottom are the same, then the one that is more center-based will have the lower standard deviation. The one that has more points on the outside will be the higher standard deviation. It is deviating more from that center point. And that's really all you need to know about standard deviation for the SAT. You know that. You're going to be able to very quickly answer these questions when they throw them at you. And again, this answer for this one is B. The standard deviation for both A and B, they are equal. Hey guys, it's Alyssa, and if you're looking for more SAT or PSAT help, go to mathwithalyssa.com. There you can get over 25 hours of test prep. This is for both math and reading and writing, both sections. They also come with practice questions, downloadable study guides, and more. Links to everything are in the description down below. Leave me a comment if you have any questions about this video or any suggestions for future videos. I'm all ears. And if this video was helpful or useful in any way, please let the algorithm know about it. Like, share, comment, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye. And I think I slapped my leg because that's something you do. Why did I slap my leg? Why am I slapping my leg as I'm talking? Who knows? I don't know.